Finally, we're looking at total surface areas. Before, we had just been looking at the lateral surface areas. So what does that mean? Well, total surface area includes all of the faces, whether they are lateral or the bases. It also includes the curved surfaces, even if they are part of the top or bottom. Really, honestly, the curved surfaces tend to be more lateral unless it's a sphere. So one thing you'll see on the math chart is the capital letter B. This can be quite confusing. The big B stands for the area of the bases. It doesn't mean like the base of a parallelogram. That's smaller lowercase b. The big capital B is the whole area of the base. All right. So for prisms and cylinders, they have two bases. So the lateral surface, the total surface area will be whatever the lateral is, plus 2b. And oftentimes you'll see plus 2b, capital B, on your math chart. For cylinders, it might actually show 2 pi r squared because the base is always a circle. So in the previous example, we had a cylinder with a radius of 8 and a height of 10. Now we're going to find the total surface area. Here you can see I have the lateral, which is 2 pi r times the height, and then I have both bases, the bottom circle and the top circle. So that's 2 of these pi r squareds. Substituting in, I get 2 times pi times 8 times 10, plus 2 pi times 10 squared, 160 pi plus 200 pi, or 360 pi. So that is the total surface area. Remember, it's going to be the lateral plus 1 or 2 bases. For pyramids and cones, it's pretty straightforward. It's just one base plus the lateral surface area. For cylinders and for cones, B is the area of a circle. Now, spheres really have no bases, and they have a different formula altogether, where r is a radius. And that formula is pi r squared. Now, on your notes, on this example, it might have said volume. This should be surface area. So we have a sphere has a surface area 32 pi inches squared, and we want to find the radius. Well, I'm going to always start by writing down the formula. Area of a sphere is going to be 4 pi r squared. Then I'm going to substitute in, this is the area right here. That is 32 pi. That goes into this side right here where the A is. Go ahead and leave the 4 and the pi and the r squared. Now I can divide both sides by pi because I know that freaks you out. And I get 32 equals 4r squared. Well, I'm almost to the radius, so I can divide both sides by 4, and I get 8 is the radius squared, or the square root of 8. Now, for my pre-AP, I would prefer that you go ahead and simplify this further. You can pull out that perfect square, which is 4, and you end up with r equals 2 square root of 2 inches squared, and 2 square root of 2 inches, and that is the radius of the sphere. So to reflect some more, not only for this part of the notes, but for the notes in general, how do you find total surface area? You have to take into account the lateral surface area plus the bases, unless you're talking about a sphere, which is a special formula. Where does the formula for prisms and cylinders come from? Where did we get that? How is the formula for spheres different from the other solids? Why can't the height of a solid be used to find the lateral surface area, then that should be an A, of all 3D solids? And which solids use the perimeter of the base to find the lateral surface area?